So the first one says find values not in the domain. Okay, so the domain is technically what numbers. The domain is what numbers x can be. Okay, so x is the domain. The domain is what numbers x can be. The range, just to mention it right here, is what numbers the y can be. Okay. So, but a lot of times it's hard to talk about the things that x can't be, or sorry, can be, because it's a bunch of them. So you figure out what x can't be and then say the domain is everything else. So on this topic, it just says finds the one that are not in there. What you do here is you kind of figure out what messes up the problem. So here you can't divide by 0, right? So anytime the denominator is 0, we can't do the problem. So what we want to do is set the denominator equal to 0 and solve that. And that will tell us what numbers x can't be, okay? So on this one, this has an x squared and an x, so we're factoring. So we say what multiplies to be positive 1 and adds up to be negative 2. So it would be negative 1 and negative 1. So x times x is x squared. And then I do negative 1, negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. And then I need to set both of those equal to 0. They're the same thing, so I'm going to get the same answer. But you add 1 to both sides. So x cannot equal 1 is what that's basically saying. If we plugged a 1 into that problem, we would get a 0 in the denominator, and you cannot divide by 0. Okay. So you always, to find what numbers are not in the domain, you want to figure out like what messes up the problem. And so anytime you have a fraction, you just set the denominator equal to 0. Okay, that's going to be our goal on that one. Now here's the problem is I have a graph. I don't think there's a ton of graphs on here, but all right, so this is the picture we are given, and we're told to find the domain and the range. So again, your domain has to do with your x's. Technically, the domain is the first element in a function, and the range is the second element in the function. But the domain is your x numbers. We know it's x and y because like x comes first, y comes second. So your domain is your x numbers. You're saying how far left the x-axis is left and right. It's horizontal, right? So you're saying basically how far left to right does this graph go? And I start on the left because the smaller numbers are on the left. We read left to right. So what I'm going to do is I basically look at the left point of this graph is at negative 4, and the right point of this graph is at positive 2. I'm going to write that down here. Okay. So we write this in interval notation. We would say parentheses at negative 4 because it does not equal. There's an open dot there. And then a parentheses at 2 because there's an open dot on the right side as well. Okay. So it's how far left to right the graph goes. That's my x values. For the range, it's my y. So I'm looking vertically. So it's how far down to up. I know it's weird to say down to up or bottom to the top, whichever way you want to look at it, but it's how far the bottom of the graph is to the top of the graph. I didn't put this number on here. I should have. Is it 1, 2, 3? Okay. No, we haven't. So the bottom of the graph right here is at negative 3, and the top of the graph is at 5. So the bottom of this graph is at negative 3, it goes to 5, and they, again, have an open circle, so I use a parentheses. If it does equal it or has a closed circle, you use a bracket. Open circle, you use a parentheses. But that's how you remember to do that one. You remember domain is your x and range is your y, and so the domain has to do with left and right. Okay, we'll talk about that a bunch today, but the x's always deal with horizontal, so you go left and right. The range deals with up and down, so you go to the bottom of the graph to the top of the graph. All right, we're we're jumping right into this one. Okay. Let me go over this for just a second. Transformations are a big part of this test. I'll go back up there if you need to write some of this. But transformations are basically, you can take any graph that you want and add or subtract it and it moves it up and down, or multiply it and it shrinks it and stretches it, or multiply by negative and it flips it, does the different things. But it doesn't matter what the graph is, because all those adding and subtractions have the same property. So first of all the different graphs that you have. So the main ones we deal with are x squared, which is a parabola. You might see x cubed, which looks like this. Square root of x. You have to be positive to do the square root, so it just goes to the right like this. Absolute value of x does a v. Do they do? They
v to the left occasionally.
They do v to the left? Okay. 1 over x is something like this. It makes a graph like this. We'll talk more about this in a section or two. Yeah, if they do, the absolute value of y is actually like this. But you may just see the picture. But the main thing is recognizing a general ballpark of what they are. I don't think you have to do that too much. I think they give it to you a lot. But those are kind of some of the different graphs that you see. I mean, technically, a line is just an x. I guess we could put that one on there. But those are some of the different graphs that we see in this class. And what it has is I call these the parent function. Okay, so the parent function is the original that you're basing everything off of. And then when you start to add or subtract, it can shift them up and down and different things like that. So for example, if I have, I'm not going to want to have to draw that thing 5 million times. So let me copy it a couple times. Okay, so adding and subtracting basically says, let's start with like an x squared here. X squared looks like this, okay? So we have the original is x squared, and we are told to make it y equals x squared plus 5. This plus 5, when you add on the way I separate these out are the outside and the inside. So this is outside of the square. So I say add 5 on outside. What that means is to go up 5. This one makes sense. Like if you add 5 to it, it's just going to start 5 higher. So 1, 2, 3, 4, 5. I add 5, and my graph now looks like I just shifted up 5. Okay. Oops. All right. So you can do this with any function though. So even if I do like the square root of x, which looks like this. I haven't been putting arrows on them, and I don't really know why. But arrow just means they go on forever. Square root of x. So that's my original square root of x. When I take that and I do it on the outside and I subtract 2, say, again, that's on the outside because it's outside the square root. So here we are, subtract 2 on the outside. So this is going to go down 2. Okay. So I move it down. I just take that same graph and I move it down 2. And it just shifts it down. Okay, so it doesn't matter what the parent function is. It will always do the same thing. If it was absolute value with the v, it'd do the same thing. If you added something on the outside of the absolute value, it'd go up. If you subtracted something, it'd go down. So the idea behind this is you got the outside and the inside. Well, I'll go to that in just a second. I'll say what I was going to say in just a second. All right, on the inside, and this works for, it doesn't matter which shape you're doing. If I have the, yeah. The inside, the absolute value makes a v, okay? If I were to do something on the inside, like x minus 2, the inside, on the inside, I know this is weird, but we kind of did this with the formula, I don't want to get too sidetracked here, but we just wrote this down on her paper. right? When we did this formula right here, our vertex was HK. Remember, we did the opposite of the inside because the formula starts with a negative. Y'all remember that a little bit? Okay. I told you this would come in handy. Anytime you are doing something on the inside, it's always the opposite of what you would think, okay? So the outside, the outside, I'll write that over here, outside does something vertically. And the inside does something horizontally. Okay? So anytime you're on the outside, it's moving up and down, and when you're on the inside, it's going to move it left and right. So like, without using math right here, common sense, when you see x minus 2, which way would you think that you move it? Like, what are you going to say? You would think left, right? Because minus 2, you just in your brain, it's just left, right? But this is where anytime you're on the inside, you think opposite, okay? So I'm actually going to move this to the right 2. Okay, so here when I subtract 2 on the inside, I'm actually going to go to the right 2. And the reason being is because the formula starts with a negative, so you just don't look at it at first. But it's easier just to think about it. Anytime you have a number on the inside, just do the opposite of what your brain wants to go to. So I'm going to go 2 to the right. So I just take this graph and I shift it to the right.
I'm sorry, why not up or down?
Because it's on the inside. So like you see how this number's outside the square root?
Okay.
So that's outside. So when it's outside, it goes up or down. But since I'm on the inside of the absolute value right here, when you're on the inside, it goes left and right. Okay. I'll put it together in just a second so you can see the difference. I'll just go back to x squared real quick. So if I have an x squared one, again, that graph is just a parabola. I want y equals x plus 3 squared. Okay. So I know our brain says plus I should go to the right, but we're thinking opposite here. So when I add 3 on the inside, I'm going to go to the left 2, or left 3, sorry. Forgot what number I put there. 1, 2, 3, I go to the left 3. Okay. All right, so just to like put this together for a problem real quick so you can see the difference. I think it's nice to see the parent function on there real quick, so let me do that real quick. So the absolute value of x is just a v, but on this one I have a minus 4 on the inside and a plus 3 on the outside. So the minus 4 on the inside tells me I'm going to go to the right 4. That's what I mean by the inside. It's inside the square, inside the square root, or inside the absolute value. So on the inside, you go left or right, and then on the outside, I go up or down. So I'm going to go 4 to the right, and then up 3, and draw my new graph. Okay, but this works no matter which one you're doing. If I have x squared, that's a parabola. Actually, let me do this real quick. Sorry. The problem you have on this is number 3 right here. Go ahead and do it because it's right here. They say y is equal to the negative square root of x. So they're saying that's my original function. My original function is this right here. Okay, we haven't talked about the negatives yet, but the negative reflects it. I'm actually going to do that next. But it's saying you're starting with a negative, so you don't even have to like know this. Okay, and then what I want to find on this one is y equals negative square root of x minus 1 minus 2. So basically what you're doing on these problems is saying, what is the difference between these two formulas, the black and the red right here? Okay? So the negative, I don't even pay attention to the negative because that's not something that's different. What is different, sorry. The -1 is on the inside and the -2 is on the outside. What is different right here is you have the -1. So that's going to go to the right 1. And then this is a negative on the outside, so it's going to go down 2. You kind of see the difference between the inside and outside? Okay, yeah, I thought it makes sense when you put it together more. All right, so I go to the right 1, and then I go down 2, and I'm going to draw that same graph. And it just shifts it to the other side there. I can draw that a little better. Okay. So I went to the right 1, down 2. All right. Now for reflections, this is honestly probably the up and down is not too bad, but the reflection is probably the easiest. Reflections, if I have y equals x squared, if I multiply a negative on the outside, blue. If I multiply a negative on the outside, that is going to reflect what they say. Now, anytime you're on the outside, it does something up and down, right? It's going to reflect across the x-axis. It's going to reflect, I'm going to write vertically right here, because anytime you're on the outside, it does something up and down. So this just takes a graph and flips it straight up and down, because you're on the outside. The outside's always up and down vertically. So it reflects across the x-axis is what they say. Because this is my x-axis, so I just fold it across that. Okay. If I have, got to think about this one for a second, the square root of x, and I put a negative on the inside. Inside always does left and right. So this is going to reflect horizontally. So I'm flipping it left and right. So what they say is across the y-axis. Okay, so I'm going to flip it left and right, so it's going to look like this. So again, a negative on the inside flips it left and right. A negative on the outside flips it up and down. Giving you a second to write. All right, I'm going to skip and do number 4 real quick because it has to do with reflections. All right, so A says y equals f of x shown. Find y equals f of negative x. And B says y equals g of x shown. Find y equals negative g of x. All right, now I got to draw these out real quick. 1, 2, 3, 4, 5, 6. 1, 2. And then 2, 6. 1, 2, 3, 4, 5, 6. 2, 6. Okay. Let me go ahead and draw this one out while I'm drawing. 1, 2. 1, 2. 7. 3, 4, 5, 6, 7. All right, so part A, they give us one graph, and then they say find f of negative x. So the negative's on the inside, right? It's kind of clear that it's on the inside now. You kind of get that pattern. So on the inside, I'm thinking left and right. So we are going to technically reflect across the y-axis. I'll show you the easy way to do this. This point right here is 2 to the right. So what I'm going to do is just go put it 2 to the left. Okay? This point over here is 6 to the right, so I'm going to go put it 6 to the left. And that flips my graph. So that, again, 2 to the right, so I go 2 to the left. 6 to the right, so I go 6 to the left. Okay? That's the easy way to do these. You just got to know whether you're going left or right or up or down. So on the one on the right, this is outside. So that has to do with up and down vertically. So I'm going to reflect across the x-axis. So the 0, 0 is weird because it's not going to change. It doesn't go up or down at all. But now I'm going up and down. So this one right here is 2 above the x-axis. So I go 2 below the x-axis. This one right here is 3 below. So I go 3 above. And that's going to flip the graph vertically. Does everybody kind of see the easy way to do that? So just all you got to know is left and right and up and down. So on this one, like, I'm flipping it up and down because it's on the outside. So this point is 2 above, so I just stay on the line and go 2 below. This point is 3 below, so I go 3 above. And that's going to automatically just flip it. All right, I don't see the next thing I'm going to do on the test yet. I guess I'm only on looking at number 5, but I want to go ahead and make sure I hit this real quick. All right, so we've done adding and subtracting and dealing with negatives. So now we got to do multiplying. And this one is the least fun. All right. I'm going to call this vertical stretch or shrink. Okay. So we're still dealing with the outside. So what happens when you multiply by a number? So if I have y equals, I got to think of a good one here. I guess I can do the absolute value of x. Absolute value of x is a v. Okay. If I were to, and again, same thought process as before, if I dealing with the outside, I think like just normal. But if I'm doing inside, I actually switch the way I'm thinking. So if I have y equals 4 times the absolute value of x, I'm multiplying by a number on the outside. So this is going to do what you think. It's going to vertically stretch. It's going to vertically stretch it. So what that means is I grab the top of the graph and the bottom of the graph and I stretch it. The other way to think about this is it's going to go up 4 times as fast because I'm multiplying everything by 4. So the graph like this is going to look more like this. It's going to go up 4 times as fast as the other one. Okay? All right, if I do, I'm about to be going. Y equals x squared. And I have y equals, not negative, I don't want to do negative, sorry. So y equals x squared is just a parabola. If I multiply by a fraction, this makes sense. What I'm actually doing is take the top of the bottom and I shrink it. I smush it down. If I smush it down, it's going to go up This one in this example is going to go up 1/3 as fast, basically. Okay? So this one is going to vertically shrink it. So it's actually going to go up 1/3 as fast as my other one.
The test is just gonna ask you to either stretch or shrink.
So far, the only ones that have appeared on the test, because I don't think I like putting those on the test, is one like this right here. This where I have number 3. Okay, so that one just did up or down, left or right. And then this number 4 right here. Okay. I usually don't put stretch or shrink on the test. We'll see. I shouldn't say that before I go through all the problems, but I usually don't. All right, so horizontal, inside. Anytime we're on the inside, think opposite. Okay? So if I have y equals x squared, and I am going to do, what am I going to do? I'm going to do y equals 5x squared. Okay? So what this one actually means is that I'm grabbing the left and the right side, and I am going to shrink it, because you always think opposite. So I'm actually going to push my hands in. So I'm going to horizontally shrink it, okay, because that's a bigger number. So the rule here, I didn't say this, I'm sorry, but the rule here is that if it's a number bigger than 1, you stretch it. If it's a number smaller than 1, like 0 to 1, like a fraction 1/3, 4/5, 2/3, anything like that, you shrink it, right? On the inside, it's always opposite. So here I have a number bigger than 1, so I'm going to horizontally shrink it. If I push it in from left and right, that actually means it goes up faster. Okay. Luckily, Alex does make this pretty easy when you're working these problems. Did y'all do these last week, or is this due this week? This is due this week, right? Okay. That's why I'm spending a little bit more time on it. All right. Y equals the absolute value of x, the last one. Y'all kind of probably see the pattern here, though. Y equals, 1/4 on the inside, 1/4 x. I'm going to horizontally stretch it, which is kind of makes sense in your head, because if it goes, it's 1/4, it's going to go up 1/4 as fast. But if I grab the left and the right side and I stretch it, it's going to go up slower. It's going to go up 1/4 as fast, basically. But what you're really doing there is it's going to the left and right at 4 times the pace. That's the way that actually works. It's going left and right at 4 times the pace as it's going up. And this one's going left and right 1/5 the pace. So it's always opposite with the inside. If we need to go work one of those problems to see what that looks like, we can. Since that's on the homework, let's finish the review. Keep going on here. Just to put this all together real quick. The order of operations, they say, is HSRV. So if you have a problem like, sure, we'll do the square root of x. The square root of x looks like this. But what if I have something like this, and I got to graph it? Here's the reason you have to do this in this class, although it's kind of annoying. I know math wasn't invented to torture you, and you have to take this class, and everybody makes you take it. Sometimes you got to take it for just because you need one more credit. But the idea behind you taking a math class is that everybody will have problems in life. When you're at work, you have problems, you have things, and you see the big problem, and you're like, I have no idea what to do, right? So that's the same thing with this problem right here. Is when you look at that and I tell you to graph it, you're like, well, that's got a bunch of stuff in it, I have no idea how to graph it, right? But then you start breaking down the problem and say, okay, well, I know the square root of x looks like that shape right there that I have drawn. I know what that 3 does. I know what that -5 does. I know what that 2 does. I know what that negative does. And you start to piece together the puzzle, and that's how you problem solve. So like those critical thinking abilities, that's why you have to take a math class, is saying, okay, I have no idea how to do this, but if I know how to do this, this, and this, maybe I can lead to doing this. Okay, so order of operations. We are supposed to do horizontal first. I was going to use blue for that. Horizontal, and then we stretch or shrink. Stretch or shrink. And then we reflect. And then we do vertical. Okay, so those are the 4 that we talked about. I honestly, the order rarely actually matters, the order here, but on rare cases it does. Okay, so horizontal shifts. This one is, I'm gonna move this so I can write. Oh man. All right, so horizontal shift. This is gonna go to the left 3. You do the opposite because it's on the inside. So I'm gonna go to the left 3. So I could draw that graph right now. Then I'm going to, so like left 3 would be this right here, right? Now I'm going to take that graph. I'm going to use some different colors here. Stretch or shrink. So this is on the outside, right? That's on the outside. So I think normal is going to vertically stretch it. It's going to go up twice as fast. Okay. So this right here is just the square root of x plus 3. This one right here is 2 square root of x plus 3. That was blue. What was that, square root of x plus 3? All right, the next thing I do is the negative. The negative is, it's on the outside, right? So I'm going to reflect up and down. I'm going to just put up and down. Actually, what I'll do here, because I did it on the other one now, is vertically reflect it, right? Vertically reflect it, so it is going to flip it down. It's going to look like this. I'm flipping that green one down because I'm on the green step. Okay. Actually, what I should have done over here is, that's red. That's green. I'll just do this one black, that's fine. All right, so now I'm on the red one. The red one, we have done all of this. So then the last thing I have to do is the plus 5. That is going to shift it down 5. So 1, 2, 3, 4, 5. I just take this red one now, and that's going to be my answer. Negative 2, x plus 3, minus 5. Okay. So obviously you don't need the blue, the green, and the red graph. We're just going from the original square root of x, and all of these pieces ends up making this graph right here. It's a lot easier to do that on Alex than it is to do it on paper as well, because you got a little tool that shifts it, then you hit a button and it reflects it, and then like you don't have to actually graph it by hand like I'm kind of doing. This is probably one of the most annoying topics in the whole class, I'll tell you the truth. But luckily, like she asked, this one's not on the test. The only ones you have on the test, so kind of back to the test review, only ones you have on the test is this one right here where they give you the negative square root of x, and all you got to do is move it right 1 down 2, okay? And then you have this number 4 right here where you just reflect it, okay? So that's not too bad on the test there, hopefully. All right, back to the test review, number 5. Another graph. Maybe I should have pulled up Alex on my tablet so I could have prettier pictures. All right, 5, 3, 6, 1, 2, 3. Okay, so this topic is intervals decreasing, increasing, and constant. So read the problem because you only have to find one of them, whether it's decreasing, increasing, or constant. All graphs are either going up, they're going down, or they're flat. So the key to this is to use your x values, because all we want to know is where. This tells us where it is increasing or decreasing. We don't care how much it's increasing or decreasing. We only want to know where it is increasing or decreasing. Okay? So all these spots right here, this was -5, -3. That's 0, obviously. That's 5. No. That's 4. That's 5 and 7. Okay. That's the numbers we're going to need. So we only care where it's increasing and decreasing. We do not care how much. Okay. So this right here would be constant, right? It's saying flat from -5 to -3. Then it's decreasing from -3 to 0. And then it's constant from 0 to 4. And then it's decreasing from 4 to 5. And then it's constant from 5 to 7. Okay. I do not care how much it goes down from there to there. I only care where it is going down. All I'm doing is identifying where it's going down. So this graph is going down from -3 to 0. And then it's also going down from 4 to 5. And you always use parentheses with these, because it is interval notation, but a bracket, if you put a bracket, that means you're like stopping there. We're not stopping there, we're just looking at it. Okay, so again, I do not care that this goes down from 6 to 2. All I care about is where is the graph decreasing. It is decreasing from -3 to 0, and then it's also decreasing in this area right here, 4 to 5, it's going down. Does that make sense? So on this problem, always use your x values, because we want to know where it's decreasing, not how much it's decreasing. Yeah, I really should have thought about all the graphs I got to do. That -1. That's kind of terrible. All right, so this one, you're looking at local minimums and local maximum. It's only going to ask you to find the minimum or the maximum. We kind of talked about this a couple weeks ago, but if the parabola opens up, it has a bottom, right? So it's a minimum. If it opens down, it has a top, so it's a maximum. So the local minimum is like kind of looking at peaks and valleys. So like, financial reports. So you have good quarters, you have bad quarters, and it has peaks and valleys. So you want to know what your high point are, what your low point are in these local areas. So if I asked you like how high this graph goes, you would say forever. So sometimes we want to ignore the forever and see what's happening, each quarter instead of just at the beginning and the end. So our local minimum here, these should be pretty easy to find, but the local minimum is at this point right here, -2, -4. So this is my local minimum. Okay. Now, This is obviously x equals -2 and y equals -4. Here's the tricky part is which one goes where, okay? The x always, just like the previous problem, it always tells you your location. That's how you identify where you're at on the graph. The y is going to tell you what your actual minimum or maximum is, okay? The way that I've always remembered this is at x is y. I know that's kind of weird, but at x is my location. That tells me where to find it. And then what it actually is my y value. So when this says all values at which x has a local minimum, well, there's a local minimum at -2. That's where it's at, okay? Then what is the actual value? That's my y, and it's going to be -4. Okay? So just like the previous problem, our x kind of tells us where we're looking on the graph, okay? And then the y tells you what the actual number is. Just like in a financial report, your x's would be your quarters or your years or your whatever, your months, okay? The y would be the actual dollar amount. That's the one we care about. But your x tells you where to find it. Hey, I don't have a graph now. All right, we got this is a 3-parter. All right, so function operations. You got 3 parts on this one, but they shouldn't take too terribly long. This is multiplication. This is the same thing as r of x times s of x. That's the way that I would prefer to look at it. Actually, I'm going to write that down here because r of x times s of x. So you're kind of separating it out. So this says you take r times s, and then x is a variable that defines both of those. But r times x times s of x. So all I do, r of x is 2x minus 4. S of x is 4x. So now distribute that, and I get 8x squared minus 16x. And that's my answer. So since it says r times s, I'm just multiplying these. That's it. On the next one, this is a minus. Sorry, that's a minus. So this is r of x minus s of x. So I do 2x minus 4 minus 4x. So combine like terms. 2x minus 4x is negative 2x. And then the negative 4, it doesn't have anything to subtract, so that's your answer. So again, r minus s of x just means I'm doing this r minus s. When you have a number in here, same idea. I'm doing r of 2 plus s of 2. Okay? The way that I would probably do this is find r of 2 and s of 2 first. So r of 2, whatever's inside the parentheses, I just plug in. 2 times 2 minus 4 would be 0. S of 2, I'm plugging a 2 into the x. So that's 8. So I'm doing r of 2, which was 0, minus s of 2, which is 8. So my answer is negative 8.
You were adding, yeah.
Oh, it's adding. Sorry. R of 2 plus S of 2, 0 plus 8. All right, number 8. Q of x equals x squared plus 6. R of x equals the square root of x plus 1. We want to find R of Q of 3. Why can I not? And then we want to find Q of R of 3. All right, so this is called the composition of functions. The composition is this like open circle thing right here. What you're going to do is you are going to find, I work backwards, plug the 3 into Q, okay, 3 into Q. Whatever I get for my answer, I'm going to plug into R. So this is a different way to write it, is this right here. R of Q of 3. So work backward. I'm going to plug it. So the first thing I do is plug a 3 into Q. If you work backwards, 3 into Q. So 3 squared plus 6 is 15. Okay? Now what this is saying is I know that this right here, Q of 3, sorry, lagged on me there for a second. I know this Q of 3 is actually 15. So now I'm going to plug 15 into R. So whatever I get out for my Q of 3, I'm going to take that number and plug it into R. So R of 15 is the square root of 15 plus 1, which is square root of 16. It is 4. And that is my answer. That's my only answer. Okay? So the composition of function says that you are plugging R of Q of 3. So R of Q of 3. So I plug a 3 into Q, and then whatever I get for my answer, I plug into R. Okay? Just trying to think of an example off the top of my head, but like, you got to manufacture stuff. So how many ever you can manufacture turns into that much cost, and that cost you have to sell in the profit. So like you have to have steps that you plug in along the way there. All right, so this one backwards is the opposite. The R is on the second, so I'm going to plug the 3 into R, and then whatever I get out, I plug into Q. So that's the square root of 4, which is 2. So now I'm going to take that 2 and plug it into Q. And that's my answer. So you plug a 3 into R, and then we get out a 2, so we take that 2 and plug it into Q. All right, C is kind of a word problem, but it should be easy. Sugar Sweet Company delivers sugar to its company. C is the total cost. S is the amount of sugar. So this is, I'm reading it to you. C be the total cost to transport the sugar in dollars. S be the amount of sugar transported in tons. The company can transport up to 30 tons. The company can transport up to 30 tons of sugar. Suppose our formula is given by C of 130S plus 1500 gives C as a function of S. Okay, so what we have to find is the domain and the range. So the domain is my X values. My X value is the input, okay? I'll write that down here. The domain is my input. So in this problem, we put in how much sugar we're creating or transporting, and then our output of that is how much it's going to cost. Okay? So our domain is always our input. It's our first value, what we start with. So they give you a multiple choice here. So this should be the amount of sugar transported. Okay. And it gives me a drop-down menu of the set of values. So what, I mean, y'all have enough information. I wrote down everything that you need right here. What's the maximum amount of sugar that I can transport? It says can transport up to 30 tons, right? What's the minimum number that I could transport? 0, right? You can't go negative. You can't do a negative amount. So my answer here would be, I'll go ahead and write it. The set of all real numbers from 0 to 30. Okay? So we are getting that because it says up to 30. Set of all real numbers 0 to 30. All right, my range is the output. So it's going to be the other one that we didn't choose. Cost, the cost, right? That's fine. Okay. Now, how could I figure out, if I know my S has to be 0 to 30, how could I figure out what my cost could be? I plug them both in. Plug in 0 and 30. So 130 times 0 plus 1,500 would just be 1,500. So that's my minimum amount. Like if I do 0 tons of sugar, I'm still going to cost me $1,500. Maybe I paid for the drivers or something like that. And then I do 130 times 30 plus 1,500. I'm guessing that is 5,400. I can double check real quick. 130. Somebody do it. 15, yeah, okay. I have the drop down. You have a drop down menu on this one. Okay, so this would be my maximum cost because I can only transfer 30 tons, so I know it can't cost more than that. So this one is the set of all real numbers from 1,500 to 5,400. And again, this is a drop-down menu, so hopefully you think about that when you see those numbers. But I think every problem does do this, where you have to plug in the X to figure out what your Y is. Huh. All right, the next one is the range and domain in context. I feel like this one's fairly easy. We'll see. I feel like there's a trick to this, and I'm not remembering what it is. All right, so your domain on this one, I guess this is like the area and the length. So Layla wanted to study how the area of a rectangle changes when the length of its width is fixed. So she calculates several and graphs it. Here's your answer. Find the range in the domain. So the domain is my X values. Okay, so this is my X values. So I'm going to a rectangle can't be less than 0, right? It only gives me the first quadrant, so it's 0, but the length could, oh, you know what? You don't even have to do interval notation on this one. It's just going to be X is greater than or equal to 0. The length always has to be greater than or equal to 0. This happens a lot when you talk about real life stuff because you can't have negative lengths, right? So a lot of times it's just X is equal greater than 0. And same thing with the range, but it's y. And I believe a lot of these problems end up being like that. You just have to remember that domain is x and range is y.
But if Alex gives you the option of interval notation, you put bracket 0, comma, infinity.
I don't think this one will let you type that in there.
Okay.
I think it'll stop you.
Okay.
But like if you do that on the test, let me know. It says write your answers inequalities too, and like the toolbox
Okay.
has the less than and greater than, and I don't think they'll let you type that, but if you wrote that as interval notation, I'd definitely give you points. All right, last one is another multiple choice one. I feel like the test got a little easier as it went along. Maybe y'all are saying no, but determine these parabolas if they go up or down. If it's positive, does it go up or down? If the number in front is positive, it goes up. So this one would be up, this one would be down, this one would be up, and this one would be up. Okay, so this is what I make you do instead of, oh, are we doing the same? We got the same, never mind. I don't have to rewrite these every time because they're the same. The same problems, okay? What's part C? C is okay. So instead of doing stretching and shrinking on graphs, this is all I have you do is look at this and tell these. So you got the up and down. The up and down does not affect whether it's narrow or wide, okay? The widest parabola is going to be the biggest number, but ignore negatives. What?
But ignore it.
Okay.
It would still be the.
Because it does, I don't.
Because, I mean, on the number line, the negative would still be the smallest number. So do you really need to put that?
Well, yeah, but the negative, remember the negative on the graph just makes it go down, right?
Okay.
And then I'm just saying, is it wide? I don't really care if it's going up or down, which one's the widest one.
Okay.
Does that make sense?
That does.
Okay. So the 4 right here is going to be my widest. Any guesses of what the narrowest one's going to be? One half. That's going to be my smallest number. Again, ignore negatives. The ignore negatives part is just going back to what we said before of the negative reflects it, right? But it does not affect how wide or narrow it is. So if it's a big number, it is going to make it wide. If it is a small number, it is going to make it narrow. Okay. All right. That is all 11 problems.